Good morning, good afternoon, good evening, everybody. My name is MC Brown, VP of Products here at Continuent, and welcome to the webinar today. Today we're going to be having a look at replicating data out of MySQL and Oracle into Apache Cassandra. Before I get started, just a few little points of admin. This session is being recorded. If you want to go in and view the recording, if there's something you've missed, you want to go in and see it, we'll post this up on the website shortly after the webinar is completed, where indeed you can find all of our past webinars and information. Also, if you have any questions, there is a panel on the right of your GoToWebinar session. If you want to ask any questions, please feel free to go ahead and ask questions during the session. I can't always promise I'm going to be able to get to them at the end. It depends on how long it takes me to go through the webinar. But if I do have time, I will answer them at the end. If I don't have time, then we put up a blog post immediately after the session where I'll answer all the questions and hopefully solve any issues you have. With those two little points of admin out the way, let's go ahead and start having a look at how we replicate data into Cassandra. So what we want to have a look at today, right? First of all, I want to have a look at, why would we use Cassandra as a destination? Why would you want to replicate data into Cassandra anyway? We'll have a quick look at how the replication into Cassandra works, and then we'll have a look at, okay, so I've replicated some data into Cassandra. What can I actually now do with it? I will also have a quick look at, future direction, some other things that we're trying to sort out and resolve. Some of which are obviously directly related to our Cassandra applier, some of which are just related to our general replication. So the first thing to deal with, obviously, is, why would you use Cassandra? Well, Cassandra is been around for a long time. It was one of the, I think it's safe to say, one of the new wave of kind of NoSQL style databases that came out actually quite a few years ago now. And Cassandra was built around the basis of being very, very fault tolerant and very, very scalable, and those two things work very, very much hand in hand. So it's highly fault tolerant in that Cassandra is typically designed to be part of a cluster, and so therefore you would have 3, 5, 10, 100, 1,000 nodes in your Cassandra cluster, and that information is written into the cluster and then also distributed around, so that in the event of any problem, there's always multiple copies of that information. And the other thing is that because of that distribution, because obviously we have all of those different nodes in a typical Cassandra cluster, it also means that it's very, very scalable. You can expand the cluster and improve your performance, improve the way that the information gets distributed, and therefore the information gets accessed. Now, the way that information also gets stored into Cassandra is also fairly critical, because it also means that we get to store information in as efficient a method as possible, and then pulling out in a very efficient manner. So Cassandra has the notion of partitions of information. So we split up data across those partitions, and that's part of the way it actually gets distributed around the system. And again, that helps us to get that data out of the system as quickly and efficiently as possible. In fact, as we go forward, when we get to the demo as part of this webinar, hopefully we'll be able to take a look at that and take a closer look at exactly what's going on there and how we can take advantage of that when we start moving our data. That does mean that Cassandra obviously has some key areas where it's used, although to be honest, it's used by a wide variety of people and customers for a wide variety of reasons. It is great for things like very, very fast online services. It's used for customer relationship management style scenarios, session ID information, etc., where you want the information to be quickly accessible and retrievable from the database, but know that the data is there. Obviously, in a CRM situation, you want to be able to be sure that the data is recorded and that everything is logged and everybody is aware of what's going on. Equally, it's also used in analytics and the processing, particularly of large bodies and volumes of information, for the very, very simple reason that it's so efficient at being able to store that information and partition it and handle that distribution and querying of that information back out. And again, that's actually going to be the focus of my demo, because that's slightly easier for us to go through and have a look at. In terms of data storage, it should be pointed out that Cassandra kind of supports storing all sorts of different information. It's unfair to say it's strictly one particular type of database. You can certainly store structured, semi-structured, or indeed completely structured information into your Cassandra database. And we're going to be dealing largely with the structured side of that, because obviously we're going to be replicating data out of a transactional database, which is itself built around tables. In terms of the interface and how you get information out of Cassandra, there are obviously JDBC interfaces or ODBC interfaces to be able to pull stuff out. It's also very practical in that we actually have a query language called CQL, so Cassandra Query Language. It is very, very similar to SQL. It enables us to go in and get the data out. And indeed, again, that's part of the way in which the replicator actually gets that information out. Now, at the moment, in terms of making that translation between the two systems, you're pulling data out of a transactional database that is going to have a particular table format, and you need to be able to reproduce that table format over the other side. We obviously have a DDL translation tool that will do that for you as part of the replicator, and that's included in the package. But I think it's fair to say that there are sometimes things that you want to do that are slightly differently. And again, hopefully in the demo, I'll show you exactly what that means when it comes to processing and extracting the information. Now, what kind of topologies, what type of structures are you going to have when you're replicating data out into Cassandra? Well, because of its highly distributed nature, and because it is so quick and it is so efficient at being able to pull out this information, I think that the key thing with Cassandra is it is very good for concentrating lots and lots of data into a single point. And so a typical deployment model within the replicator is going to be our concentration model, our fan-in model, where we're taking data from a wide variety of different source databases, and by variety I mean just different MySQL or Oracle instances, and we're pulling that information in. You want to be able to take all of that information in and ultimately write it out to your standard Cassandra instance. Now, obviously, this is the replicator. Those of you who have watched previous webinars, previous training sessions, know the replicator, know that we actually support a wide variety of topologies that we can handle here. We're doing fan in here in this demonstration. We could be doing fan out. We could be replicating to a variety of different targets. But this kind of concentration of information is a typical one. And again, the real thing with Cassandra is that because it is highly efficient, it is very good at taking in very, very, very large volumes of data very, very quickly, which is why it's often used in kind of the logging, the analytics style databases and transactions. So if you were taking information from multiple sensors, or you're consuming logs, etc., information from various sources, and want to concentrate it out into your Cassandra store to be able to do your analytics, provide alarms, whatever it is you're doing with that data, that is a typical deployment model that you would see. Other systems, other models are available. Obviously, we have the benefit with a replicator that we can take all of that information, we can augment and I was going to say improve it. Improve is probably the wrong word. We can augment the information as it goes through the process so that we can add extra data. You want to know, the source database. You want to know the source host name, that kind of information. You want to add that into the data as it gets transferred across. We can do that for you. We can pull that information in and put it into the raw data that ultimately gets applied out into Cassandra, making it very, very much easier for you to take that information and move it over without having to make changes to your application or your environment. Now, in terms of how things work, so fairly typical model. I'm not going to concentrate too much on the how we extract the data, except to say, obviously, we can pull information out of Oracle, we can pull information out of MySQL and the derivatives, Percona, MariaDB, etc. Once we've got that information, the layout for how the Cassandra applier works is slightly different from some of the other webinars that you may have seen just recently. So Cassandra is an example of a batch-based applier, and by batch-based applier, what I mean there is rather than taking the information out and applying it directly into Cassandra by writing the data into Cassandra itself. What we do is we take that information, we generate a CSV file of the individual transactions, and then we ultimately take that information and write that into Cassandra. First of all, into a staging table. Second of all, we take that information and ultimately write it into the final table. And that last process is done within Cassandra. The CSV files that we generate contain all of the changelog information, and some customers actually do find that very, very useful in order to be able to take and have a look at all of the changes of the information rather than necessarily just the verbatim kind of carbon copy basis of the information. Once we get the information up into the staging table, it contains information about the operation type, the commit time, and obviously the individual data itself. And then we actually merge that information within Cassandra by taking the information and representing that data and saying everything that is listed in this CSV file that is marked as a delete it in our base table, in our carbon copy version of the table. And then, everything that is an insert the latest version of that. And by the latest version, I mean, obviously, you could potentially modify the same record a number of times. And so what you want to be able to do is you want to be able to take the last version of that, and that will be the version that is now the current version of the row in the target table. And this is what enables us to get this carbon copy version of the information as we move it across. Now, when it comes to something like an update, what we actually do by default is we take an update and we mark it within the CSV file as a delete of the original information and then an insert of the new information. Now, while all of this actually sounds like a relatively convoluted process in order to get this data across, the reality here is that we use batching when writing into target databases like Cassandra because it tends to be much, much more efficient. The method with which we can move that data across and get that data into Cassandra, and indeed our other databases where we do this, it is much more efficient because we can do it at 10,000 to 100,000 rows at a time, and transfer that information and get that data over into the system as quickly as possible, compared to potentially writing out single transactions of writing that data. Now, in the case of Cassandra, you could argue that possibly the difference would not necessarily be that huge. Cassandra is already a fairly efficient and quick system for handling those kind of writes. But let's give it the benefit of the doubt. I've actually done testing with our Cassandra environment, and I ultimately decided that the benefits of the batch-based system was that we do get this changelog information, which potentially you could keep if that's what you wanted to do. And therefore, there's an extra level of practicality that you would get with writing the data into Cassandra through the batch system, but also it enables us to control how quickly and how efficiently we actually get the data over there into Cassandra. Again, I actually want to demonstrate that as we have a look at the demo, because I think it's worth understanding what's going on behind that process and behind the scenes. Now, when it comes to actually applying the data and how we do that, obviously we can't just take verbatim information from a MySQL or an Oracle source and write that directly into Cassandra. We do have to handle the fact that we are processing row-based information. This is heterogeneous replication. We're not translating SQL statements, right? We actually have to take the individual row information, extract it as individual rows of data, so that it can then be assembled into that CSV file that gets written out as the raw data. As I mentioned earlier, and let's just dig into this a bit more. We do have to handle the fact that there is this difference, this change within the DDL within Cassandra. We do have our DDL scan tool, and the whole benefit of being able to use this DDL scan tool is what DDL scan does is it goes over to the source database, so in this case MySQL. It reads the existing table definition and then translates that into a corresponding DDL definition within the Cassandra environment. And again, I want to show you, when we go to the demo, I want to show you how that is practical and how that is useful from the perspective that we make some changes as we do that. For example, Cassandra doesn't have a character data type per se in the same way as we understand it within MySQL. So Cassandra is a NoSQL style database, and so what you actually get is there is a text, a data type, rather than necessarily a char or a varchar data type. So there's no fixed length data as it gets written in. And that kind of reflects the unstructured, semi-structured nature of Cassandra in terms of a target database. There are a few other changes. There are a few things that we have to cope for, that you might want to have to cope for in terms of how information is modified and translated across. One of the things that sometimes trips people up with Cassandra is it has relatively limited date data types within the system. And so, timestamps, date, time, etc., that kind of information. There are limited options available within Cassandra. All of those things are currently handled on some level within the DDL translation. That doesn't actually modify the data, but we can, if we wanted to, we could go ahead and add filters, etc., when we go ahead and modify the data through the replication process. Now, future release, we added this great DDL translation tool in 5.3. It's not currently supported for Cassandra, but ultimately it will be. We'll obviously be making that available so that we can handle that DDL translation automatically. There are certain things that we want to be able to do in that DDL translation tool, particularly when going out to targets like this, where we want to be able to change or improve the data, the structure, etc., as it goes out. We'll be covering that DDL translation tool in a future version. You'll be able to see what it's capable of. But again, we'll try and have a look in the demo and kind of see and understand what's going on behind the scenes in terms of how that works. Now, before we get to the demo, I just want to talk a little bit about the demo data structure. What I've done is I've basically created a very simple table over on the MySQL side, and that very simple table contains a load of sensor data. Now, I am at this point actually faking the sensor data, and the reason that I'm faking the generation of the sensor data is because I want to be able to generate a huge amount of information in a relatively small period of time. And so, I'm trying to simulate what would probably be, an hour, a couple of hours worth of sensor data, and I've also exaggerated the temperatures and such to make it a bit more obvious and dramatic that something is going on. The actual data set and environment that I'm using here was part of a logging project that I did many years ago. It's still in place now. And it's still writing and writing that information out into Cassandra right now. As a general rule, the sensors themselves were in a building, and so relatively they don't change very much. Obviously I've changed that so that we can be a bit more efficient. Over here on the left, then we have the information as it exists within MySQL. We are actually taking this information and we're moving it out. All of the sensors have their own name. I'm using strings here again, just to be a bit more visual here for the demo. But all of that information ultimately gets replicated and moved over into Cassandra as the same thing, put into the same table. We use primary keys. I used offset primary keys in the source database as you would with a kind of a multi-master environment. There are other options available for what we can do and migrate that information. As I mentioned earlier, we've got the ability to add like table names, etc., into the data as it goes across. So we could actually add a unique name to every single row of the data as it gets migrated and replicated over into the target Cassandra environment. Now, again, there's lots available here. I'm doing this as a demo so that you can see exactly what's going on and what's under the hood. And I'm trying to simulate something that would ordinarily obviously take a little bit more time. But just so that you understand the basic structure, so that we'll be able to get the information out. So let's have a look at the the demo. So what we've got here is on the left hand side. What I actually have here is I have a MySQL database, and I am very deliberately here running trepctl, which is our replicator control. This is just showing the status information. So this is what the replicator is doing right now. You can see that at the moment it's idle. I'm not running any load or anything at all on here. Over here on the right hand side, I have the Cassandra instance. Let's just resize that window to make it a bit easier to see. So over here, I have the Cassandra instance, and again, you can see, you know, at the moment everything is running and up to date. So just over here in a separate window, I'm just going to fire some data through here so that you can see things, and I'm very deliberately actually going to generate a relatively large body of information because as it's going to go through and do this, I want to kind of talk about what's going on behind the scenes here. So over on the MySQL side, over here on the left, what's happening here is the information is being written out into the MySQL database. We're pulling that information out. We're putting it into our internal format, which is the transaction history log, the THL. As that information gets pulled out and put into the THL, we're making sure we've got information like primary key and other data, and then ultimately it gets applied over here on this side with Cassandra. So you can see the activity on the MySQL side. That's actually less interesting to me as far as I'm concerned. But let's have a look at what's going on here. Now you can see as the data comes in with this quick status information, you can see here, right, we know how far we are behind in terms of the number of transactions. I'm very deliberately writing each individual row of this demo data into the system as one individual single transaction or one single row. And you can see that we are writing the information here, and you can see that ultimately we appear to be getting behind, right? So the typical method for us having a look at writing data into a target database is you want to have a look at the latency. You want to see how quick that data is going in, and you want to see what's happening. Now, what's really going on behind the scenes here is the batch applier has come into play, right? So what happens with the batch applier is that we collect together as many rows as you have configured in the replicator together, so that we write that information out efficiently. It's no good us taking, you know, writing out one single row into a CSV file and doing the import, or even applying that single transaction. We want to write out 10,000 different rows into a single file so that we're applying it, and that is exactly what is happening here. I have the semantics here are written so that we are writing out 10,000 rows at a time into our CSV file. And so what you will see is that this number here, which is actually indicating how many transactions have been applied over to the target system, it's going to look like it's stationary for a bit, and then ultimately it's going to look like it's caught up, and it will stagger itself accordingly. So I've just written all of that information in. Let's run that again. You can see here. So we're 1034114. You can see it seems to be relatively idle, and then in a couple of seconds you will see that this number will suddenly reduce as we write that information in. Now these batch parameters are configurable, right, and they're very deliberately configurable so that you can set how quickly you get the data across. You can see that you know, obviously the latency here is as it's shown here, is actually relatively high, but it's relatively high because I've set the parameters to be high, right? I've actually set a period of 10,000 rows or every 10 seconds. We're going to try our best in order to keep within that, according to how quickly we can ultimately write that data across. And we're coping with the fact that we're writing that information out. Now you can change those parameters if you wanted to do it every second and every 100 rows. That's fine. Be aware, however, that in a batch environment, that kind of writing of information and how quickly you get the data across, you're going to start getting into the point where it ceases to be real time if you set the numbers too high. If you set the numbers too low, you may not be able to write the information efficiently out into the Cassandra service. Now, the other thing to mention is I'm looking here at one individual service. I could have had 5 services or indeed 10 services ultimately writing their information into the Cassandra system using the replicator and doing it in parallel. And if you were doing that and you were writing the data out there back into Cassandra in parallel, obviously things would appear to be much faster because we'd be writing so much data in, because we'd be doing it across so many different source databases and source tables and writing the information in. Now, while it's just processing that, that's actually less interesting. Let's actually have a look if we can. Let's just have a look if we can. So this is our DDL scan tool, and the reason why I'm showing you this is what this generates is a version of the table based on the source table within in this case MySQL. You can see here that we've gone ahead and created some basic information about the table. So we've recreated a table. We're using text instead of char or varchar. And we've also set a primary key, and we've set that primary key automatically based on the ID primary key that we would have in the table. Now, generating the information in this way, it does mean I can actually modify the table. And what I have actually done within the sample table within here is, if we go in and have a look at the table as defined within Cassandra, you can see that what I've actually done is I've added an additional primary key here into the table definition within Cassandra. And the reason that I've done that is that primary keys within Cassandra are ultimately used as a method of partitioning and organizing the information. And that is, they become a very, very quick way of you being able to access and process the data as it goes through. And that means that it then becomes very, very much more efficient for you to be able to pull the data out in terms of getting that data back, because we can take advantage of that partitioning within Cassandra in order to speed up the querying of the data when we get it back. Now, the other thing I should mention is, obviously here I'm using a primary key on the information, and I've deliberately actually got a unique ID primary key over on the MySQL side. I could be using like compound primary keys. I could be using a variety of things. One of the things we introduced or will be introducing actually in the 6.0 version, which is coming out very, very soon, is we do now have a customization of the primary key information. So if you have if you have tables rather that do not have primary keys, or maybe don't have the primary keys that you want, but you want to be able to use a specific set of primary keys when you go over into the target database, particularly in a batch environment like this one, you can now define the primary keys on your source table as it comes through. We actually created this for a customer who had an Oracle application, and the Oracle data that was going into the Oracle database. Within Oracle, you have this notion of a row ID, and so you can use a row ID as a unique identifier in order to be able to pull it out. And that's great, but that row ID information is not so useful when it comes out to the other side. Even if we tracked the row ID information when it came out, that row ID is not actually guaranteed to be unique for the life of the data. You change the table definition, change the index definition, etc. That row ID information changes and it becomes useless. However, the data that was in there and the rows of information that were in that table were actually uniquely identifiable by using the data that was written. So what we did is we created an extension to our existing primary key filter that pulls that information out, that just enables us to change that primary key data as it goes in. The source table was generated by an application that they were using within the Oracle environment. And so although they could have changed the definition, that could have potentially broken the application, or the application would have not liked it, or would have reset it and said, no, this table is not supposed to have a primary key on it, and changed it. By having this custom primary key solution, you're able to be able to change that. Like I said, that comes out in 6.0, which is, at the time I'm doing this webinar, is actually coming out very shortly. So returning just to this to this demo for the last bit, one of the things I wanted to do is, obviously we can go in and have a look and just see how big how big this data is. You can see there's 370,000 rows, not a particularly huge amount. You know, this is running in a VM on my laptop here. But let's go in and pull out the data and extract the information. I've probably used there we go. You know, running a query there, you can see the query is run and come back relatively quickly. I am having to use filtering in here. I am having to process the information, but you can see how we can very quickly get the information back out of Cassandra. Again, you can see, you know, we're doing aggregation. I've not done anything clever, particularly with the Cassandra tables as they stand, other than adding that additional partitioning key, which would help for certain types of query and certain types of processing. But you can see how we got the information out. We got the aggregation. You know, we're processing through quite a few tables on a single CPU VM and getting the data out very quickly. You can see that information goes in. What I will do, let's just do one last demonstration, and let's see if oh, and there we go. So I'm writing data in now. You can see that you know, the data is changing. Obviously, there's such a large number in there. We're kind of tending to what you would expect for something to be able to produce. We're going to tend towards the middle of an average and the extremes of a max and a min. But you get the idea. You can see that the data is going in and that it's writing correctly and getting in there very quickly. So that was the demo. You know, hopefully that's given you an idea of how quickly we can get the data in, you know, what kind of customization, etc., is available in terms of the replicator. You know, in terms of future directory, we are always expanding the replicator, and at the moment we are working very hard in order to make sure that we get the data, the modification, etc., over and out in the correct method. That does mean that we are adding new filters, we're adding new methods of expanding and controlling that information all the time. That peaky customization that I mentioned is a good one. You know, we're doing it with you know, adding database names and obviously also modifying information, so date time and other information as it goes across. We're also adding things like data obfuscation. So if you want to be able to remove like credit card data or PII data as it goes across and have that handled relatively automatically, the replicator will be able to handle that. There are actually filters, etc., out there that will do that already. We're just trying to standardize on those and make them, you know, a bit more practical and a bit more easy to use. And obviously, we can merge data, we can change information, we can augment, add additional rows, etc., as the data go across. We're also trying to work on, you know, other methods of reformatting and reformulating the data as it goes across over to the other side. So that it can be more useful in those situations where you want to handle, you know, unstructured, semi-structured information, and you want to be able to control that. That's something that has largely come out of our appliers that we're now doing for Elasticsearch and Kafka. But obviously, we're moving that into other areas where we see fit according to what customers want and use. In terms of other future direction, like I said, we're always adding new appliers. We're always adding new filters, etc., into the product, and just keep your eyes peeled. So you know, that's the end of the webinar. I hope you've been able to find this useful. You know, if you want any more information, you want to you know, maybe have a closer look at our Cassandra applier, you want to get in touch with us, you have any questions or anything, you know, please feel free to get in touch. You know, all of the information is here and available online. I would be remiss if I didn't mention that obviously this webinar is part of a series of webinars and a series of training courses. We have a new session every single week. If you want to go and have a look, you know, please feel free to go and have a look at Tungsten University and indeed all of our past videos and information. If you have any questions, unfortunately, I'm over time now. If you have any questions, you have anything you want to ask, you have anything that that didn't make sense after watching this video, please feel free to get in touch. Contact me directly, MC Brown. My email is on the screen right now. Get in touch, ask questions. Hopefully, if you've asked a question, I will be answering those immediately after this session. But always come to us. Always come and ask questions. Any questions, etc. you have about the replicator, any recommendations or suggestions for improvements. I'm always willing and ready to listen. In some cases, we'll see what we can do for you. But there we go. That's the end of the webinar. I hope you found the session useful. I hope this has ignited your interest into Cassandra and indeed the replicator itself. Hope you've enjoyed it, and thank you very much. Enjoy the rest of your day.